well, this is for cutting 2D polygons made of straight lines, closed and not self-intersecting, into axis-aligned rectangles that are in 2 dimensions. It cannot be a line. Like this, for example. It cannot be a line. We start with something like this. We get what points intersect with this rectangle. If there are no intersects, it is either entirely outside or one is entirely inside and another. How we can tell is all point parts inside another for that. Anyway, we get what intersects on both of these shapes, and for axis aligned and rectangle, we can add vertices when needed. We go from a start point, finding what it connects to, and we know that we measure it a specific way. Say in this instance, it would be going this way, and it would be counterclockwise. More counterclockwise as then, and next and less as then would be to preceding in angle makes for in. So in this case, we're going this way. And in that case, we're going this way. These two things connect in here, so we have our shape. Now, what about if I have a line like that? For that, you have to find all intersects, but here it's all intersect on line with rectangle. Measure end and inside on one end and end inside on another end. So say this would be a part, this would be a part, and we just find, say, measure it going this way. You can and do this with area. So this way. So then anything this way. So to here, we always want to connect it back to origin of start. And then we have that again. But what about for more complex shapes? Like this. We get these things that intersect. We define a direction that we're going. In this case, again, counterclockwise. And so go from here. We know that this is connecting inside. And we go from here to here, and that we know is connected. Now, what about, say, this? We define the way it's going, which is clockwise this time, and we define all things that are intersecting. So we have this way is in because it's clockwise from it. So let's start at a point. We go here. Next on line is over here, and it's connected to over here. So we end and with that, and this one is going this way. So at here, we now have a shape. And this only works when polygons are, as said, straight line, closed, and not self-intersecting. That sort of thing also counts as self-intersecting. Although it's technically something like not. Now, what about if we had something like that? We count this thing twice because both lines have an intersect there. But what if we had this? At that point, we only count it once because as there is no inner or two lines. If there are two lines going inwards, then count it twice, otherwise count it once. And keep going in the way that it should go until you find and back to origin. So let's define this thing. Note that I am defining it as if it's on the perimeter, then it is in. If it is completely outside, then it's outside. Going clockwise this time. From here, this way is in. So find here to here. And that has an in part. So next point set. No point set should have things in common, except for when it's an intercept like this. So, like this thing is a different entity than this thing with no common points. But then, and we have this way is in, this way is in, we now have a connected thing. Thank you for watching. If there is any problem with this, tell me. XE.